final session for today. And the title is the analysis of the dynamic behavior of the composite slab from Miguel Iglesias. Okay.
Good afternoon. My name is Miguel Iglesias, and I'm here to present the paper entitled Analysis of the Dynamic Behavior of a Composite Slab, carried out by the Mechanical Engineering area of the University of Cantabria. The contents of this presentation are those shown in the slide. First of all, I'll begin with a brief introduction. The new construction trends in floor structures point towards the improvement of characteristics such as the insulation, both thermal and acoustical, the fatigue strength, and also the reduction of assembly and transport costs. These needs lead to the use of lightweight frameworks like the soft core sandwich panel of this study in the building industry. These frameworks, composed of foam core and fiber reinforced plastic skins, fulfill these demands, but as a drawback, they present a slightly worse stiffness to mass ratio, which also implies a worse dynamic behavior, which is the aspect that motivates this study. Well, floor structures are designed for ultimate limit states like the strength, stability, durability, but also following serviceability criteria, such as vibrations and deflections. For slender floor composite structures like ours, these second serviceability criteria usually govern the design. And hence, the stiffness, mass, damping, and the dynamic excitation suffered by the structure become even more important than the strength of the materials utilized. In this aspect, very basic design recommendations are presented in the Eurocode, and weighting curves for the human response to building vibrations can be found in the ISO standard. These ISO weighting curves are applicable to the frequency range of 1 Hz to 80 Hz, where the most annoying perception levels occur. Well, in this paper, we'll focus on vibrations. The main aim of this work is to analyze and to optimize the design of the composite slab with respect to the vibratory behavior. To achieve this goal, an experimental model testing was carried out, as well as a finite element simulation and several sensitivity analyses. Now I'm going to introduce you the lightweight slab case of study in this paper. We were tasked to analyze the dynamic behavior of a specimen, and we also tried to determine which one of 2 parameters was more sensitive in order to improve the overall dynamic behavior. In this slide, you can see the slabs mounted in a prototype 2-story building. The slab is composed by a sandwich type laminated of epoxy resin and glass fiber skin of 2.5 mm thick and an expanded polystyrene core of 200 mm thick. Its dimensions are 2 meters long and 1 meter wide, and its mechanical properties can be observed in this table. The core material can be considered isotropic and the skin material as orthotropic. With respect to the experimental part of the paper, the first 4 vibration modes were experimentally determined to be able to validate the later finite element model. Well, the slab was hung up with 6 rubber ropes, as can be seen in the slide, in order to simulate the free boundary conditions. The rubber ropes were connected with the slab by means of clamps. A grid of 15 points was defined in the slab, impacting in each point with an instrumented hammer and recording the response with accelerometers. Thus, frequency response functions were obtained, which were used to identify the modes. The first 4 modes obtained are shown in this table, being the lowest one of 90 Hz. Once we have determined experimentally the vibration modes, it was time to create a finite element model of the slab. This finite element model was developed in an Astram pattern environment. The skin was meshed with planar cell elements, and the core was meshed with hexahedral solid elements. Each clamp was modeled as 2 mass elements rigidly connected in the opposite direction. I can show you the results of this finite element analysis are shown in the second table, as can be seen comparing the modes obtained both experimentally and numerically are pretty coincident. I can show you now one video of the first 4 modes. The first mode is a twisting mode at the frequency of 90 Hz. The second mode, a bending type mode, it's found at about 100 Hz. The third mode, another twisting type mode. And finally the fourth mode, another bending type mode. Okay, now we arrive to the optimization of the slab. The goal of this work, besides the mere execution of the model analysis, were to optimize the slab design from the point of view of the dynamic behavior. Thus, the frequencies associated to the first modes should increase as much as possible, moving them away from the range of human annoyance to higher values. In order to achieve the same, 2 parameters could be modified: the skin thickness and the total slab thickness. To determine which one of these parameters would offer best enhancement of the dynamic performance, 2 sensitivity analyses of the mode frequency variation were carried out. In the first sensitivity analysis, the thickness of the skins was modified. As we can see in this table, the more the thickness, the higher the frequency. In the second sensitivity analysis, the thickness of the whole slab was modified, while the skin thickness remained constant. Again, the increase of the thickness correlates with an increase in the frequency values. At this point, it was necessary to define a new parameter which related the skin thickness variation with the total slab thickness variation to consistently compare the model frequency variation of each of the sensitivity analyses done. This new parameter can be found in another aspect that should be taken into account when optimizing the design of this slab. And this is the total manufacturing cost variation. In this chart shows the increase of the first mode frequency with respect to the increase of total cost when either the total slab thickness or the skin thickness was modified. Well, as conclusions, the dynamic behavior of a composite sandwich construction slab was studied, and the first 4 vibration modes were successfully determined by means of experimental model testing. A finite element model was developed and adjusted, matching the experimental results quite satisfactory. Sensitivity analyses were carried out to determine the most sensitive parameter for improving the dynamic behavior of the slab, and the result was that the slab thickness is more sensitive than skin thickness in terms of manufacturing cost. Thus, it is recommended to increase the slab thickness in order to improve the dynamic behavior. This is all. Thank you very much for your attention.
Okay, thank you. Is there any questions? No? I have a question for you. No problem. You can keep. I see that you put in the finite element model the characteristics on the parameters of the elastic modulus and the mechanical parameters of the materials, the composite and the both, the sandwich. But it comes from experimental tests, or it comes from a database, from the theoretical database, or what? Okay, so this data also is a result because you are adjusting this data to perform the comparison between the theoretical and the experimental tests. So that's the way. Okay, thank you. So I have to read, but I think there is no present. The next communication is the evaluation housing financing performance of the Federal Mortgage Bank of Nigeria. Is there? Is present? No. No. Imposed housing sector reform area. No. Okay, he isn't. So the next communication is merging innovation with technology on building envelopes system to control on the environment force. Okay, no. So, following, the next. I think there is a sunny day. Yeah, people in the beach. Okay, the next, I think so. Government versus civil society, an approach to affordable housing developing in Thailand. Okay, thank you. It's in the desktop. Yes. Okay. And I don't know.
Where?
Oh, a second.
Oh, okay.
Oh yeah.
Yes. Good afternoon, everybody. Today, I would like to make a presentation and want to share with you about the governments and the civil society and approach to affordable housing development in Thailand. Thailand and your country is very far from here, around 6,000 miles here, and I think housing is very difficult. Different of the European country, right? The first of all, I would like to introduce you about the housing problem in Thailand. The first, we have the slum. I think you know the slum. Slum, most of the country, the European country, also they have the same problem. And also this is the map of the Bangkok metropolitan. It's a capital city, and we have the two problem. One is the substandard housing and environmental. The second is slum eviction. And the people always enforce live in the slum, and they have the small space, crowded, lacks of the basic infrastructure and hygiene and environmental conditions, lacks of the basic tenure security. And the second is the slum evicted. The number of the slum evicted in Thailand, and we have allowed 300,000 units should be to keep away. The first of all, and you must know the easy to understand the household income distribution in Thailand. Actually, the low income should be have the is under the 50 percentile. In the case of the government and the civic society, and we have allowed 30 percentile. The household income per month allowed 300 euro, and the civic society, civic group allowed 200 euro. It's very cheap. Yeah. And it's the meaning of the slum and the lack of the parts of the city and housing live in the bad condition. Yes. And should be go quickly. The problem of the slum eviction, many times we found that in my country. One is the slum eviction by fire, and you will see this is in the city. In the town, the slum live in the town, and they will meet the fire. And when they meet the fire, and the results or the consequences, like the destructions of the institute social and the survival network, and destructions of the life saving and the family access, and increase of the cost of living, and worsening the condition and poverty cycle again. And after that, when we have the fire and we don't want to move, and they want to live in the temporary house, and government they just come to solve them the problem. Ultimately, the the housing. We hope we will make a housing like a home in the final, like this. And the final, we hope the security of the land tenure. This is my purpose of my study. Recently we have the new policy for low income and the grassroots for allow the 5 years ago, and the public and the civic group also they try to organize and to solve the housing problem. And it's for my case study, and we want to follow up an evaluation of the new policy for low income will carry out by the public sector and the civic society, because we know that housing is the one measure of the nation. The international development should be parallel of the in my developed country. This is my theme of my study. Okay, and we hope the outcome of my once we have the invest for the one housing should be have the accessibility, affordability, and sustainable. It means the economic well, social and political, include the social coherence should be in the community, and environmental security, social and self-worth, and healthy and personal security. This is this policy we want to get up. Many strategy for housing solution in the public housing from the 1980s to the 2006. We have so many strategies like the slum upgrading on site, slum relocation, slum reconstruction, slum relocation, and land sharing. Also have the science services scheme and flat walk-up apartment and detached house, and so on. Many is tied to solve the problem and provide the housing for them. For the new policies, the mechanism of the housing solutions, we divide the two organized. One is the public housing. They're just like construct the housing like the mass product, because we have a lot of the housing shortage, and we must to construct them like the mass. And the second way, we have to give like a quality of the development. It means the demand driving community. And so many agencies just come, university or in NGO and the community come to join and to solve the problem them. Especially the residents should have to organize the community network, because we don't have more to organize by the official, and we need the community in the whole country to make the network. In the same time, the residents should be organized the saving credit, and decide they negotiate to buy the land and decide the housing by themselves. Well, make the welfare, the community, enterprise, and environmental concern, and etc. should be do in that community. This is a process of the civics group, and they must to find a good way for them, like when they want to solve the problem. Some and another place is different, and they will choose the slum upgrading or slum land sharing or reblocking or some mixed development. This is in case of my case study. The public housing they provide or they construct the house just like the mass, and it's really you just saw that it's like the good environment, good infrastructure, good playground, and really nice the pedestrian. And another project is from the slum. the civic group that try to solve the problem, because this case study, the sector along the river bank, and the landowner, they want to move them out to another side. You will see that housing, they're living in along the river bank, something like this, and they try to negotiate with the landowner many times and many years, and fortunately they try to buy the piece of land, just like the case of the land sharing, and they try to move for the 50 house to, living in the orange piece of land. And also the people that try to organize themselves, and just as the first they will set up the saving cooperative, and they decide the community by themselves, and they will talk every night, and they build a house by themselves, and taking care of the environment, and taking care of the elderly, taking care of the children in the community. And also they will make the social network to share knowledge in the case of the evicted slum, because we have many cases to solve them. This is the case study. When they develop themselves, you will see the people, they can choose with the post site they want to live there, or they want to live with among the council, or they want to meet among the friends. Yes, and this community they decide by themselves. Okay, and the conclusion. The finding of the public sector, we found that the government that try to give only the one group for the project, and it's not good to make the socio-economic development. The second, the government or the public sector don't prepare the education for the target group before the allocate them into the community, and it make them have the lacks of the sense of belonging, and the site location is far from the working place, and problem of the operating for implementation, and it's very important is political intervene in the public sector. And for the civics group, and we found that we will meet the democracy changing and decentralized, and issue of the city and the financial issue should be to talk in of them. This is the good luck for the low income, and we have a chance in the future that will develop the community. And low income policy should be mixed. For my study purpose, that should be mixed income, the group in the project development, and should be decide the community the first step before the physical design, and emphasize the community-based approach. And also we need the site selection to near the workplace or the transportation, and public and private should be to encourage the affordable housing. And the government should be encourage or make incentive in affordabilities for the private sector. And also is 5 factors for strategies. Enforce of the neighborhoods residents as the institutes, and developing the capable or effective the neighborhoods governments, and increase of the public and private to invest in the affordable housing. Rebuild the community as the capacity of the community. And should be proposed to optimize between the optimize and the base, and the nation transfer of the resource higher values, and the very important policy for to make the home as home buyer for the in the housing market. New construction should be not expensive for the households and should be support the financials. Thank you very much.
Okay, thank you. Thank you to put light in the problem that appears between the government and the civil society, especially when people miss their flats. Thank you. Is there any question? No? So, sí, mira, yo no. Okay, so let's continue with the next communication. In this case, is titled "The Requirements of the Spanish Technical Building Code, Energy Efficiency and its Application on Concrete Building." So we return to the concrete now. Okay, from Arturo Alarcón.
Thank you, Mr. Chairman. I'm delighted to be here and to have the opportunity to present to you the results of the study that have been carried out by the Spanish Institute of Cement in collaboration with the Eduardo Torroja Institute and the Castilla-La Mancha University during last year. The main idea was to assess more exactly, to compare the behavior, the energy performance in terms of energy consumption of two buildings. One made in a traditional way and almost in Spain, I mean concrete structure, but joisted slabs and facade and inner partition made of face bricks. And the other building made entirely in concrete, slab concrete and inner partitions and walls of facade made of reinforced concrete. We tried to assess the effect of the thermal mass of concrete using the tools provided by the Spanish Technical Code for Buildings and the official software that should be used for this kind of analysis, the LEADER and the Calendar software. But let me begin with this data or sustainably in the context of construction that you probably may know because they have been presented this morning by the President of FEN. But let me remark only two data. The margin for savings can reach 200 megatons of CO2 per year. That is a very relevant data. And this is very important. These emissions are due to the use phase of the building, are emitted during the use phase of the building. Our contribution from the housing sector, in my opinion, should be buildings with the aim of being inherently savers of energy from the very beginning of its service life, and very important for free. That is what exactly we propose in our study, in our research, with this project, Sustainable Concrete Solutions, complying with all the requirements of the building code regarding energy performance that are currently exist or are yet to come. The questions that we have tried to answer with this study are the following. Which property can be provided by concrete to the sustainability from the environmental point of view in a building basis? Is the energy consumption of buildings different with different thermal mass of its structures and its building envelopes? can be balanced in economic and embodied CO2 terms, the difference between a traditional building with a concrete one during its service life. You can see the first question is related to the main effect of concrete regarding the thermal mass, and we can understand how the thermal mass work. You can see in the slides the effect of the insulation during the day entering by the hollows of the facade. The head is storage by, in this case, the concrete slabs. Keep in mind that the inner partitions are also made in concrete and is released during the night when the temperature decreases. This is a real effect which can be detected in a double way. The former is a smoothness of the curve of the outdoor temperature that is in black in this diagram. And the later is a gap between the two curves, the outside and the indoor temperature. The result is that the temperature inside the building is within always the comfort area, providing net savings of energy, as you can see in the slide. This is a real effect. Here we can see the effect of the thermal mass in different locations in Europe provided by the passive own European project. It's in Lisbon and in France, I think. And this effect, of course, can be quantified. But how we can do it? Our approach was the following. The first step was to simulate the energy demand of the two cases, the traditional case and the concrete one, in order to assess the energy demand of both cases. The simulation was performed by the Eduardo Torroja Institute, who was able to exploit all the internal data, the quantitative figures provided by the software that usually are not accessible to public. And the second step was to calculate the structure in both cases in order to determine what was the cost of two buildings. The aim was to try to the second question. It is possible to compensate the extra cost of the concrete solution by the energy savings provided by the thermal mass during the service life of the building. And the calculation of the structure was performed by the University of Castilla-La Mancha. And the third step consisted of assessing an environmental balance of the building in terms of CO2 emissions, compensating the additional CO2 embodied in the concrete mass compared with to the traditional solution with the savings in energy consumption, considering an average figure for CO2 for heating and cooling the building during all the service life of the building. This is a view of an infography of the building. There's the basic characteristic of two cases for the same building, I insist. M1 is the traditional case, and M2 is the concrete one, the concrete solution. Here's the floor plan and front elevation. Is 14 flats per block. Inside this closed block, it's usual to have sport facilities as swimming pools and leisure area for children, etc. This is the typical layout of the typical standard house with 100 square meters and 2 bedrooms, 2 bathrooms, and 1 living room. The calculations were made taking into account some assumptions with the aim to make equal, to make a fair play the previous condition for the calculation for both buildings. For example, same quantity of hollows and its surface on the facade, same transmittance coefficient complying the technical code for every climate area studied, service life in both cases of 50 years, etc. This diagram represents the energy demand in absolute figures for different climate areas. The difference between the traditional option and the concrete one depends on multiple factors, mainly the climate area and also for the type of climatization, if it's cooling or heating, but as an average value in a city with a medium climate severity is about 16%. This percentage includes the contribution of the thermal bridges that in case of concrete solution doesn't exist, but in the case of the traditional solution are unavoidable due to the peculiarities of the old system construction. Keep in mind that the insulation in the concrete solution is placed on the outdoor sides of the facade. Two additional results coming from the calculations are the 16% that I have mentioned before, and an 11% extra cost of the concrete solution coming from the calculation, dimensioning and pricing of the structure. With this data, it can be concluded that the reduction in the cost of climatization of the building compensates the additional cost of the concrete solution in 14 years. And as well, the period to balance the concrete embodied CO2 to the indirect emissions avoided during the life cycle of the building are 16 years. Also, as single data, the CO2 avoided during the whole life of the cycle of the service life of the building is near 10 tons of CO2 per home, which is a modest figure, but we have to think in the total number of houses that are going to build per year around the world. This is a diagram of the behavior on a heavyweight construction building and a lightweight construction building that it crosses the balance of 16 years, but it's important to show that the behavior of the heavyweight construction it's an advantage from the energy point of view. Let me finish with a real example of what I have present. Is the Mataró building. It's located in a residential town very close to Barcelona, and it's a public promotion of the municipality of Mataró for young people, for young single people. It's an apartment building, and it was constructed in 1995 and is working without any problems from the very beginning of this commission of the building, and with an excellent energy performance. The key characteristic of this example, in my opinion, is that the project was conceived as a design criteria with the objective of using extensively the thermal mass of concrete, the material in which the building has been made of. Slabs, facade and inner partitions are made of concrete. This is the curve of outdoor and inner temperature. And when I say extensively, I mean that the thermal mass in this case is activated 2 minutes. Because the heating system is inside the concrete matrix of the slabs. You can see the tubes of the heating system coming from the slabs, the concrete slabs. And this makes that the capability of concrete to extract energy is enhanced, and also to release it after later. With this activation, with this thermal activation of the concrete, the energy savings rises up to 40% compared to an equivalent building. And this 40% has been certified by the University of Polytechnic University of Catalonia, who has monitored the main parameters of the building during a long period of time. As a conclusion, it is possible to compensate the CO2 emissions during the service life of buildings. There's energy savings by the combined effect of the thermal mass and the absence of thermal bridges of 16 in average. The payback period are reasonable, and activating the thermal mass, we can achieve very relevant energy savings. And of course, we are benefiting from the rest of contribution of concrete to sustainability. Long service life, fire safety, resistance, compartmentalization, strength, and of course, structural stability. Thank you very much.
Any questions? Okay.
The insulation was of the outside.
Another question? No, I have one. This is a specific question because it's related with the software that we use in the modelization, in the buildings envelopment. Which software that you use? The Rojas Institute, I think. Leader.
Yes.
Okay.
They was able to explore all the internal data of the software.
Okay. So it is possible. It is able to put each element of the facades.
Yes.
You can put it. But you assign the same thermal conductivity and something like that, or do you change in order to see what are the changes, the variability of the energy consumption?
Is the same coefficients of transmittance, and
same.
And they put the insulation, enough insulation to comply the Spanish code.
The requirements.
The requirement of each climate area complying the Spanish code.
Yeah, the CTA. Okay, good. Thank you. Thank you very much. Very interesting. Okay, let's continue with another one. I have to read at least the following the action schedule. A strengthening of reinforced concrete element using carbon fiber elements into the extraction. But I think there is no present. So the next and the last one is full characterization of a new composite materials by Ana Bassa. Okay, thank you.
Good afternoon. I'm going to present a part of my PhD study that is not concluded yet. So I'm going to do thermal characterization of thermally enhanced mortar with phase change materials. This presentation is divided in 4 main parts. The scope, an introduction to phase change materials, the experimental study about the thermally enhanced mortar developed, and some conclusions. The project goal is to develop composite materials to improve thermal comfort of residential buildings in Portugal. We pretend to introduce phase change materials to brick walls or concrete walls, mortars or insulation materials like traditional and actual materials used in residential buildings. This study aims a complete characterization of the main physical and thermal properties of the thermally enhanced mortar developed so far. Why Portuguese residential buildings? Traditional buildings are adapted to geological, geographical and spatial climate diversity of Portugal. The climate is very moderated. It's a Mediterranean climate, however, the energy consumption in heating and cooling due to the constant improvement in thermal comfort is increasing every year. This is just an evolution scenario, but what we can see in our homes is that we are increasing the consumptions in heating and cooling demands. This image shows the evolution in the construction of the building's envelope. We pretend not to radically change this way of construction, not to bring the lightweight construction, for example, but to improve the existing materials with these new phase change materials. What are those materials? Those materials are used for latent heat storage, and we call them phase change materials because in the phase transition they are capable of store heat. This heat is released in a constant temperature, and that's the real benefit of these materials. The water is one phase change material, but we can use that in buildings because the temperature of melting is 0 degrees, far from the temperature of comfort inside the houses. So we must have raw materials with melting temperatures around 20 degrees. Phase change applications, we can find them in tents, in sportswear, in medical or materials, food transportation, in medical treatments, and you can already find them in buildings too. To be used in buildings, phase change materials must be encapsulated, macro-encapsulated or micro-encapsulated. The raw materials used are paraffins, fatty acids and hydrated salts because they present the melting range of temperature around 20 degrees. And with these raw materials, we intend to use those with the melting enthalpy as higher as possible. However, those are not the only properties to have in mind. These materials have to present physical and chemical and economic properties as well. And so, in this application, we used paraffin wax, micro-encapsulated paraffins. We achieved a solution with 25% of PCMs, phase change materials. But to achieve this, we have to try several different formulations. First samples were made only with sand, cement, and 50% of microencapsulated paraffin, but the solution was not presenting very stability. And then we start to put little amounts of resins to bind the components together. As the results were not satisfactory, the formulation was changed and we start using only 25% of phase change materials. The results were not satisfactory as well, and we have to substitute the sand for an industrial filler. And then, with some rearrangements, first we substitute a small percentage of cement for chalk, and then we achieve the last formulation with very good results. We performed some physical tests like compressive strength, water absorption, and many others. For thermal characterization, we performed differential scanning calorimeter, and the results that we achieve, it's results very near to a common mortar, a common a commercialized mortar regarding physical tests. And in thermal tests, we perform the differential scanning calorimeter to the phase change material alone and to the mortar with phase change materials. What we could see is that the phase change materials in the mortar formulation conserves its properties. And so the properties of the PCM alone is with a melting temperature of 24 degrees, around 24 degrees. This phase change material in specific, but we can have many other similar materials. And an enthalpy around 100 joules per gram. Results that we achieved so far show that it is possible to obtain a thermally enhanced mortar without disregard physical properties. The best proportion of phase change material was selected, 25% in mass fraction. The composite material developed offers the following thermal properties: transition temperature around 24 degrees, latent heat storage 25 joules per gram, and the thermal conductivity we assume that it is approximately to a common mortar around 1 watt. Okay, thank you.
Thank you. Any questions? PCM, okay.
What kind of test do you use to determine thermal conductivity?
The thermal conductivity.
The thermal conductivity, we already tried to perform, how do you call it, hot plates, but we didn't have success. We are trying that again. However, we assume to have different changes in that thermal conductivity because when the material is melting, the thermal conductivity of phase change material is a little different. It's around 0.2 when the material is solid and 0.18 when it's liquid. It's a small difference, but we are trying to achieve that differences in the composite material. It's not being, it is difficult, but we are trying to with another method, CT meter. I don't know if you know that equipment. However, the normalization of mortars attributes to the thermal conductivity similar to the mass, around 1. If the mass is if the mass of the mortar is around 1 kilo, so the conductivity is 1 watt meter per gram. Is with the density of the material, exactly.
And also it is important to control in the experimental test the moisture
Yes.
present, because it could be changed. But
Yes,
I think they use the typical
Yes, the typical.
to measure the conductivity. The thermal
yes,
conductivity is with a cold plate and a hot plate, and to establish
We have a
achieve
problem with that
thermal-
because of the rugosity of the plaque. The plaque
the-
was not perfectly.
really
Yes, and we have.
could be
str-
roughness.
Yes, and we have
no
results, very bad results, but we are trying to do
But
it
you
again.
can isolate this. You can put a form or like to focus on to provide a continuous and a stable flux.
Of energy.
Energy.
The difficulty is to have the temperature that we want to. We want to test it with more than 24 degrees and less than 24 degrees, and this is difficult. But we have another method with CT meter equipment, City Mètre is a French equipment with a
French equipment,
French technique.
City Med.
City Mètre, I think it's called like that. It's not so, the results are not so good as the black ones, but the temperature can be controlled. The temperature of the blacks can be controlled.
Yeah, okay,
Mortar
because
plaque.
there's not a way to isolate the material. I think it's like a pulse, a heat pulse that propagates inside the material. It's like a hot wire. of
Yes,
the
and
material.
material has to be very, not with air, not with,
Not with rot.
not
Shape.
rough,
Shape.
very short, yes.
Okay. And I don't know, I don't remember if you put the percentage or it's a secret, the final percentage that you find.
I present them. It's not a secret.
Okay, it's like 25%,
Of phase change materials, 5% of shock.
and you
Okay.
have determined the cost-benefit ratio because
We are
expensive.
already development. It's a work in. We are advancing in this work. We have finite elements methods to do the thermal the thermal behavior of this mortar applied in. For now, it's just for little boxes.
Yeah.
With 13 to 13 centimeters
Okay.
square, but we intend to put them and construct in situ installation
Is it installation to control the temperature outside and inside?
no, the temperature, the inside temperature without with materials, without phase change materials and normal materials, and
Yeah.
we are comparing that with the finite elements method that we developed.
Yes, you can compare the evolution, the temperature's evolution between in both cases,
Yes.
with and without PCM materials,
And this
and also with different orientations.
yes.
If you want to perform in situ test,
With a
Yeah.
big window and solar
exactly.
south window. This work with like thermal inertia, but with the improvement that the temperature is controlled in the melting temperature.
Yes,
So,
exactly. The point is the melting temperature for
Yes.
each specific application.
Yes.
Okay. Okay. Very interesting. Thank you. So, okay. Another question.
Yes, we had problems in the initial performed examples in the small boxes, but the adherence is near a common mortar with only this percentage of phase change material.
Okay. Any questions? No more? So let's continue now. It is finished the schedule, so I think there is time, but I only want to remember that the closing ceremony it's at 6:30, 6:30 at the auditorium. Okay. For the closing ceremony for the directors. So I think you have enough time. Okay? Thank you.